In this video, we are going to be using what is called the quotient rule to find a derivative. And so basically, you're going to have functions that are written as a quotient. So I like to call it the top of a fraction divided by the bottom of a fraction. Okay? And so there are two different ways that you can memorize this rule. So when I first learned it, I was always told to take the derivative of the top. So this prime symbol tells you derivative. Multiply it by the bottom. And then you actually subtract the top as it is multiplied by the derivative of the bottom. So it's just like the product rule, except we are subtracting instead of adding because we have a top and bottom. And then you divide by the bottom part squared. Now, once I became a teacher, some of my colleagues shared with me a little saying that they had. And so if we wrote the function as high over low, just meaning that you have a top part, which is the high part, and you have a low part, then they were taught to take... they would take the derivative of the high, so they would say high d, meaning derivative of the high d low, minus low d high, so derivative of the low times the high, divided by low squared. And it kind of had a little, I guess you could say a little tune. High d low minus low d high divided by low squared. So however you do it, the key thing here is that you are subtracting between the two. So you're taking a derivative of a top times a bottom minus, or you're taking derivative of the high times the low minus. So the key is subtracting in between the two. Okay, so when we look at this first example and we're asked to derive it, we're going to start out with taking the derivative of the top. So the power of 2 comes to the front times the negative. So that becomes a negative 2x to the first when you decrease that power by 1. Put it there so you can see it. The derivative of the 1, of course, is 0 because that's a constant. So there's my derivative of my top or my derivative of my high. I'm going to multiply it by what's on bottom, or what I'm calling my low. So just leave that as 7x to the 5th plus 7. And then here's the key. It's minus. So this fraction bar can help you remember that it's a minus sign between the two. All right, so now we're going to take the derivative of the bottom. So if I pull the 5 to the front and multiply, that becomes a 35x to the 4th. And then, of course, the derivative of 7 is just 0. So the derivative of the low, or the bottom, is multiplied by what's on top, or the high, so negative x squared plus 1. And then don't forget, the whole thing is divided by the bottom part squared. So we have a 7x to the 5th plus 7 on bottom. It gets squared. Now, they do expect you to do some simplifying. So if we go ahead and multiply negative 2x times the 7x to the 5th, we get a negative 14x to the 6th. Notice you add those powers. And then negative 2x times the 7, see what happened to my pen, negative 2x times the 7 becomes minus 14x. All right, so then we come over here. We've got to make sure to carry this negative sign with the 35x to the 4th. So negative 35x to the 4th times negative x squared, that actually becomes a positive. That's going to be a 35x to the 6th. And then negative 35x to the 4th times 1 becomes negative 35x to the 4th. And then on the bottom, they do not expect you to FOIL that out. We're just going to leave it as 7x to the 5th plus 7 squared. So now we'll go and we'll combine like terms together. So notice I have two terms that have x to the 6th. So negative 14x to the 6th plus positive 35x to the 6th is going to leave me with 21x to the 6th. And then the other terms I can't combine. It doesn't really matter. But I'm just going to put them in the order that they appear. or it's typical to put them in order from highest power to lowest, which you'll see that's what they've done down here. But technically it does not matter as long as you have those terms there. And then don't forget about the bottom part squared. So there is my final derivative based on the quotient rule. Okay, so once again, we're going to do the quotient rule. So we'll start with derivative of this top part. So 4 times the 12 becomes 48, and that becomes x cubed. And then we have a plus, pull the 2 down, and that just becomes 2x to the first. So there's my derivative of my top, or my high. That'll be multiplied by my low, or my bottom. And then, because it's the quotient rule, we're saying minus. All right, so now we're going to take the derivative of the bottom, or the low. So that becomes, pull the 2 down, negative 6x. And then the derivative of 5 is 0, so nothing there. And then that is all multiplied by the top part, which I'm going to have to squeeze it in here. 12x to the 4th plus x squared minus 35. And then the whole thing is divided by the bottom squared. So negative 3x squared plus 5, that whole thing on the bottom is squared. Okay, so let's clean it up and see what we have here. So if we go ahead and we're going to have to actually FOIL here. If I multiply that, let's see, 48 times a negative 3. I'm going to get a negative 144, and then that is x to the 5th power. And then on the outside, if I multiply 48 times the 5, I get plus 240 times x cubed. And then on the inside, 2 times negative 3 would be negative 6, so that is times x cubed. And then on the last, 2x times 5 gives me 10x. Okay, so now as I continue, I'm going to go ahead and distribute. So when I have minus negative 6, that's the same as saying plus positive 6. So 6x times 12x to the 4th, that is going to give me a positive 72x to the 5th. And then we have 6x times x squared. So that will give me, let me just come down here. That's going to give me a positive 6x cubed. And then we have the 6x times the negative 35. So if I multiply that, I get a minus 210 times x. And then the whole thing is divided by negative 3x squared plus 5 squared. Okay, so as we look at combining our like terms together, the first thing that kind of jumps out at me is this negative 6x cubed and positive 6x cubed. Those actually cancel each other out. And then if I look at, I've got a negative 144 x to the 5th and a positive 72 x to the 5th. So that actually leaves me with a negative 72 x to the 5th. Plus, I don't have any other x cubed terms, so that would be a 240 x cubed. And then I have a positive 10x minus 210x, so I'm going to be left with negative 200 times x. And then once again, that whole thing is divided by negative 3x squared plus 5, that whole thing squared. Okay, so at this point, we've got to bring in our algebra skills to simplify this. And what I notice on top is that all of those terms are going to all have a factor of negative 8, and they also have an x to the first. So I'm going to factor that out. And when I do, from the first term, I'm left with 9x to the 4th. From the middle term, I'm going to be left with minus, that'll be a 30x squared. And then from the last term, I'm going to be left with plus a 25. Now, what this has created, of course, then the whole thing is divided by negative 3x squared plus 5 squared. And I'm going to write it like this for just a minute so that I can show you in a minute what's going to happen. All right, so now on top, that is a perfect square trinomial that will factor. So we've got the negative 8x And if we factor that perfect square trinomial, we're going to have a 3x squared minus 5 times itself, a 3x squared minus 5. And again, notice on bottom, I've got those two, but I'm going to rewrite them. I'm going to take a factor of -1 out of each of them. So when I do that, then that makes this a positive 3x squared minus 5. And then when I take a -1 factor out of that other one, I also get another positive 3x squared minus 5. So now you can see a 3x squared minus 5 on top cancels a 3x squared minus 5 on bottom. Another 3x squared minus 5 on top cancels 3x squared minus 5 on bottom. So on top, you're left with just -8x. On bottom, -1 times -1 would be +1. So -8x is your final answer.